This is the ASME Dynamic Systems Control Division podcast series, and I'm the host Yao from Texas Tech University.
And I'm host Hao Su from City College of New York.
All right, so today we are very fortunate to have Professor Anna Stefanopoulou to join our discussion. And for those of us from the ASME community, we're very familiar with your work and the leadership through the years. But just for our new audiences, how would you like to start introduce yourself, Anna?
Sure. Thank you very much. First of all, I want to say for having me and sharing your time and the cold under even the cold conditions we're facing today, even down in Texas, I heard. But anyway, so my name is Anna Stefanopoulou, and I am a professor of mechanical engineering at the University of Michigan. I'm also the William Clayford Professor of Technology, which was title Galip Olsoy, another amazing scholar in our area, had before. And just to my background, I'm actually jack of all trades. I took my bachelor degree, what you call bachelor degree in Greece, in naval architecture and marine engineering. So I
Wow.
worked with ships. Then I did my PhD in electrical engineering. Now I teach mechanical engineering, but I think you know that I do a lot of chemical engineering. So there you go.
Yeah, thank you, Anna, for joining us today. Because this is our first episode of the podcast series, I would like to give a brief introduction for our audiences what this is about. And so this is actually motivated by the starting of the unfortunate pandemic from last year. I feel like most of us from our community are feel working isolated. We don't feel like connecting effectively as we are in person. So that's when we start this kind of podcast initiative. And Helen and I volunteer to be the host for the first few episodes. And so that's the motivation and why we want to do this. And hopefully this can be a good channel for our community, even maybe after this pandemic. And so speaking of this current situation, how does this impact of this remote working affect you? I mean, most of our work research, some of the research can be done probably remotely, but what about the experimental ones? How does that work for?
Well, I can tell you, my students sometimes are very happy that I'm not around and I am from my home because they used to say that I'm not supposed to touch this experiment. So it's rough. It is hard. It's hard for us that we're doing experiments and the groups and myself.
Yeah.
But on the other hand, um, at the University of Michigan, at least, things were organized really well. We shut down really quickly. We moved from home, so we kind of rushed in the first few months. We wrote papers and we went back and
Yeah.
refreshed our lab books, and we did a lot of cleanup, which we haven't done. And so it is, as you can see, welcome to my home. I am here at my basement, although it's nice and sunny down at my basement. And I am working down here. My husband is working all the way up at their bedroom. He took over the bedroom for his office because he's also teaching, so he's a lot in Zoom, and we're both loud, and my daughter is in the middle layer. So we are one of the privileged people that we have the ability to separate ourselves and be on Zoom and not get mess each other's feed line. So everything is okay so far.
Wow. That's I feel like it's very difficult to get used to this new norm, and I think everyone need to figure out a new way to be adaptive. Yeah. And how about mentoring students remotely and organizing remote meeting, and how does that impact the mentorship scenario? Yeah.
I think the most difficult part in this environment, which is the remote,
Ah.
is the experimental again aspect. A lot of my students have to, when they join at my group, they know that they will be working all the way from modeling, from experiments, from data, from physics, modeling, and then all the way to the controls and back to the implementation of the control to the system.
Right.
And so it's nice when we can all be together. My student, as you know, our students teach each other.
Yeah.
And you are in the same office and you can ask questions and you know to who to go and ask the questions. The same thing in the lab. You watch and you see and you shadow in the beginning and you learn really quickly how to do experiments and not to set yourself on fire. Protocols and all that. I mean, things had to be a lot more rigid now. And unfortunately, I think what is impacting, it's more the newer students that they're walking in and they don't have the ability because of the physical distancing we're imposing and the low occupancy in the labs.
Yeah.
We still do work. We work with shifts and my students kept on working, but we have to think a little bit because you gravitate with your friends. And so I don't want to have like all my senior students together and all my junior students together. And so how do I make it so that it's natural? I think that's the part that I think it's the hardest, but once you get together and you discuss about it, then actually the students realize it and typically works out okay.
Oh, wow. I think that's very impressive. And I'm still struggling to organize the lab meetings, and also mentor my students to do, because we do a lot of wearable robots, assistive robots. So we need to do a lot of experiments. In particular with the human, with patients. So that's really, really difficult because we are not really allowed to take those external visitors, patients to the university. So that's a kind of like a very unique challenge for my lab. Yeah.
Clinical research is the one that is the hardest to perform right now, right?
Right. Yeah. And then maybe I can start to ask you a little bit of researchy questions. And maybe I think over the years you have developed a very pioneering and high caliber research program involving control, automotive, and energy system. Could you please share with us, how do you get interested in those topics at the beginning?
So as I mentioned, I'm a Greek native. So I was born and grew up in Greece. And, over there, we always love the sea, and the only industry we have over there, well, one of the best industries we have there is our maritime industry. So I followed naval architecture and marine engineering, which was one of the best departments. And I always liked mechanics and stuff, to take things apart, and so it kind of was natural to me that I would work within the naval architecture and marine engineering. I would work more on the propulsion of the ships. And so I was trained in computer-aided design, automation, and propulsion, like the engine rooms.
Oh, wow.
They're in these big ships.
Yeah.
And then I came here in the United States to actually work on automating systems for navigating in the Great Lakes. You would think, why a naval architect came in the Midwest and in Michigan? Well, actually, Michigan has as much coastal area. The coastal line is as much as Greece in Greece.
Oh, wow.
Because we are in between the Great Lakes.
I see, yeah.
So we have a lot of, it's one of the best departments. And so I was lucky. I came here for a PhD. And I loved more and more the controls, the parts that, were new to me. And so I came in Michigan as a graduate student. And I was trained in electrical engineering in doing controls.
Yeah.
I worked on engines, and so energy, fuels. We always had the issue about efficiency. We cared about emissions and pollution. And at the end, taking it even further, I was always interested in alternative energy and alternative propulsion.
Yeah.
So that's why I did a lot of work. I work on batteries, fuel cells, and engine control.
Wow, that's. I think you have very diverse background in many different areas, and in the very when you started like, your faculty position, did you kind of like struggle to really think about the several options to pursue in the beginning?
That's a great question. Nobody has asked me that. It's like, yeah, you're right. So, this is what I say to my students.
Oh.
I don't plan everything. I actually plan very little. I just follow opportunities, and I know, I mean, I have the general principle. I want to study interesting things that have impact. Um, you know, kind of be pioneer, like not work on things that have been there for a really long time. I want to move around. So with that natural tendency, I have to explore new areas. When I started as a faculty, I went to my advisor and I said, could you give me an advice? What should I do? And he said, Jesse Grizzle was my advisor, and he said, oh, I'll give you an advice, find a good student. And I'm like, okay, yeah, but I cannot control that. So give me your second advice. Find a good student. Find
Wow.
a second good student.
Yeah.
So actually, I took that at heart. I think when I attract students, I try, I give them a topic, and then I try to understand what they're interested in. So actually, when I switched from internal combustion engines to fuel cells, was because I had a student that wanted to do it.
Yeah.
And I said, okay, I've been working, my thesis was in internal combustion engines. I see a dynamometer after dynamometer, all these facilities. I'm surrounded by these amazing automotive manufacturers. So we're just doing always engines. Maybe I should do something else. So I guess that's how it worked.
Yeah. I think that's very inspiring for I think I mean maybe at least for me as a junior faculty, I think I do agree. I think the students are really important for our research, right? And I spend a lot of time to recruit the best students that I can find, and and I think that's super important and very helpful for me. Yeah.
You sit down and you ask them, or I mean, sometimes they don't know, right? But I think you give them some options, and some students will actually, in my past, students have actually led me to do new things.
Yes. I have a similar experience. One of actually my first PhD student, his background is on like a motor, electric motor. So I have been trying to do this, but I really struggle to find the good student. But I was very lucky to have him as the first student. He's really good at electronics and customization of motors. So that's why in my lab, we can make the motor really lightweight and really suitable for wearable application. Really expand my kind of like domain from like a mechanical design to kind of like a motor design, some more electrical, this kind of like domain. Yeah, that's super interesting. Yeah.
Yeah, and speaking of that, and you just mentioned that starting from the internal combustion engine to fuel cells, and we see a lot of changes over the years in the automotive part, and and I guess this is also the buzz. I guess the buzz around that. What will be happening for next decade? Let's say we see all these disruptive technologies about the automation, the connectivities, the electrified transportations, the powertrains have been changed as well. And I guess not only for me myself, because my research obviously is directly related to that, and I would like to ask for your vision on that. But I guess this is probably of great interest for a lot of our audiences. How do you see this evolved in the future?
Yeah, so it is actually, exciting, first of all. But and there's so much, um, I want to say, rush to get to do a lot in that area, to push, to move, but there's so much need. If you think about it, if you look at the projections associated with global warming, um, we need to have something like, if you project also all the business as usual, which includes, all the billions that have been announced by automotive manufacturers about electric vehicles, let's say. I mean, we are still 500 million, so 500 million of vehicles behind the targets we need to reach by 2040 in order to, maintain within 1.5 degrees
Right.
warming. So it's I kind of feel like the responsibility
Yeah.
that we need to do a lot. We need to do them fast. On the other hand, I know that we should not overshoot. At the end is the integral of CO2 that we're exposing our environment, we're sending out. So we soon overshoot, we soon rush in, maybe, pushing towards electrification in areas where the grid is not so clean anymore. So what our society, the division of dynamical systems and controls, could help so much is like understand this, also the deployment, the transition,
Yeah.
how to happen timely and in different regions that make sense,
Right.
so that at the end we try to minimize as much as, we go as fast as possible down our greenhouse gas emissions, but we do it also in an equitable way, because at the end there's always demand and cost and the market needs and the supply.
Yeah.
But we need to ramp up a lot of things like lithium, mining and processing. And if we rush to do it too quickly, maybe there are emissions there are toxicity there. How do we think about it holistically so that when we develop the electrified vehicles,
Right.
it's not, it's really cleaner, but also better for the society than, internal combustion engines. Myself, because I'm also a female, a woman, I really want to have, I want to take my electric car to a machine shop that I can have girls there working on
Right.
it.
Right. Right. Absolutely.
So yeah, it's extremely exciting. My students are in, we just keep on working nonstop. We read papers. It's so interesting to be in this field.
Yeah. I mean, as you said, this is exciting and probably in the new areas of significant changes are upcoming here. And you are in this position of pioneering work, and then you feel like this kind of responsibility of making this happen in this in your work, like the equitable way. And I guess this this entire problem is so big and so holistic, and when you're trying to solve it from different angles, there are a lot of challenges. And then, like in your mind, when you're trying to tackle this bigger problem, what will be the highest priority you want to start with first?
Well, so I mean, there are problems in technological problems in the technology, which you would address with research. But I think in this transition, which is what also is important, is there is a workforce development that we need to do,
Yeah.
and not just our new students, that they are coming in and they could, try to change the world and do the right things and come up with the innovation. Um, I want to actually also help with the people that might lose their job and they were leaders in, developing transmission systems and gearings and things like that. How are they going to be trained really quickly
Yeah.
to contribute in the new direction? Because at the end, we need all the help we can.
Right.
It's not like we can do this with like half of the world, or so, and definitely we don't want to have two separate societies. the ones that can actually afford going into the electrification and get batteries in their cars and batteries in their homes with solar and, get to be greener. But then that you have an entire, world that can't do that.
Absolutely. Yeah.
So this is, I think, the part that I'm also scratching my head about, what can I do
Right. Right.
Yeah.
to help with the transition in beyond, the higher education.
Yeah.
Right. Yeah. When you talk, I think that's a really important, maybe a little bit overlooked aspect, right? And when you talk about maybe the workforce development, do you have any some thoughts and some either activities or some future things you want to do to promote workforce, or maybe like a female students, or some underrepresented students to get involved in this kind of community research area?
Yeah, what we're doing with my group and the College of Engineering and right now is we're trying to work with start working a little bit with community colleges that maybe they will offer certificates or 2-year degrees that they would improve their learning. We're also or condense the learning, or target, because in community colleges you have to target employees and employers. Um, and then I think the other part that I find also interesting, and we're trying to do it, is to also help just regular people, communities that they're interested in. There are all these nonprofit organizations, and there are all these, in cities, they're trying to, understand, where do we put charging infrastructure? It's not only the utilities can do it, and then, but if the businesses, like, when you have a small business, you don't know about it, then maybe you will not want to do it. And I guess, how do we create a little bit more help? We help the community to understand some of these issues with just kind of watered down information a little bit, not too much math. So this is what, we're just trying to help, or just at the same time understand what is the public considering as the big problems. And how do you communicate also what we're doing with respect to how it can impact them and change them. And I think that's useful. I mean, it feels like you kind of waste time. You could be writing more papers, you could be pushing farther, do more experiments. But maybe, I changed because of the COVID, and because we have to rethink a little bit what we're doing. But I kind of stepped back a little bit and thought about it. And we have to ask questions about, what do we do about the others, that they're not just higher education and leadership, but just plain people around us.
I think you are maybe in a really great position to really think about this and actually do something to create a broader impact, right? Beyond the kind of like higher education. I think that's something. I think that's something really, really important to for the workforce development and also the overall bigger community.
Yeah. So I haven't figured out exactly yet what it is. and how to do it effectively and productively. But sometimes you have to try things, and you just follow your guts and
I always get a lot of like email from some like high school or even middle school students from New York City, or even like New York State, from Albany. They say, "Oh, I want to learn robotics, in particular those medical robots," and they feel like a robotic prosthesis, and like Elliot Rose does, right? I mean, we do a similar like a wearable robotic research. People are really, oh wow, this looks so cool, and I try to help them a little bit, but it's not very easy because there's no program, right? And I can help them through summer internship, but yeah, I'm trying similar like you do. I think I'm trying to figure out a little bit better way, maybe every summer. But now because of COVID, it's really almost impossible to mentor them remotely, right? For those high school or middle school students. Yeah. Yeah, I think when you talk about the workforce development, I think maybe for your students or your postdocs, do you have what's your kind of like advice for them to start an academic job or start like an industry job? Maybe for two different like different kind of like interest groups. What's your advice for them? Yeah.
Well, what I did served me well. I have to say I've been very fortunate that sometimes I took the risk to start something new, and it paid off. And when you start something new, you put your mark and you make your impact. And at least for academia, that's what we want. I think, like you say, when you're assistant professor, you have to kind of do this maybe 30% or some percent of your time. Don't put all your eggs at that thing.
Yeah.
While you're working on finishing other things that you're well known. I also think what helped me a lot, and that's not exactly a plague for our society, but it is, and our division, I was very lucky. I went to a meeting in back there. It was the IMECI when we were part of the IMECI, and I went to one of the division meetings, and I sat in the back. And in one of the breaks, some of our senior, back then executive committee members came and said hello. And I introduced myself and I said, oh, I just graduated and I'm working. Back then I was actually in industry. I was working at Ford Motor Company. And I said, well, I came because I didn't know many people. So I came to see how, what is the division meeting? And I learned so much and I made friends. And this way, I think that's what I would also really advise new, my graduate students, is to make sure that they do participate in the division meetings and they learn how the division works, how they can contribute in conferences and special issues, and just learn how we run and we connect our community, and we try to, at the end, highlight the best things, make connections to industry, educate our students, and all these other things. So it's very good good network.
Yeah, it's funny you mentioned that. It reminds me of an incident that you're saying that to reach out to the ex-cons and other peoples in the networking. I remember that was probably several years ago. I was just in my second year PhD program, and I was doing the presentation in the ACC, and you were sitting there. And after I finished my presentation, I want to talk with you. I think that because I follow your work very, very closely. At that time, I was so shy and afraid. I mean, how should I reach out? And she's there. I mean, and at the end of the day, I just I just finished the presentation, and I feel like this is now you are sharing this. I think this is probably be very good suggestions for our graduate students, particularly.
Yeah, I tell my students, we are busy, and the older you get, the more kind of like 5 minutes here, 5 minutes there. You can't concentrate on too many things. So I tell my students to, when they want to, I actually, I tell them, do your homework. When you go to a conference, map out your sessions.
Yeah.
And try to read. If you want to meet certain people, read their paper or their previous paper, and be ready to engage in a discussion that is specific to their work, so that this, this way is the easiest way to
Yeah.
actually get somebody to, that is more senior to know you and to remember you,
Yeah.
because we meet so many people, and hey, the older we get, the less we remember. I mean, I am terrible with names.
Yeah, I mean, this entire experience, I think, for conference and utilizing those opportunities for graduate students are particularly useful, and either for networking for the academia, and also sometimes I think the conference nowadays we have this kind of industrial sessions that help students to secure a job, and probably particularly important in this current situation that the openings are limited. And you mentioned that you work in the industrial briefly before you move back to academia, and
Mhm.
this I assume that these two options are probably still two most popular options for our PhD graduate students nowadays. And so when those PhD graduate students they are graduating and they decide which way they should go, do you have any suggestion for them to consider that? What are the factors you need to consider if you want to pursue one of them?
Well, I mean, I it 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 depends. It depends what industry. It depends. It depends always. Also, industry is such a big statement. It's just
Right.
a big. It depends. Is it a startup? Is it a big established
Yeah.
company? Is it a company that has R&D and devotes time and effort to their R&D, or is it a company that it's kind of more manufacturing and so it depends. The Let me flip the question. Maybe no, okay, I'll answer. So the issue is that I tell my students, again, I like what I did. I decided that I really need to understand how the industry works. I needed a network. I needed a little bit more experience. And so I was lucky in the sense that I managed to go work in industry, but in a very high caliber research environment. So this way I kept on writing papers and I kept on being very active in the research world.
Hmm.
In fact, in all honesty, in our division, we value so much our industry participation that I felt, because I was industry, I was privileged to, everybody was inviting me in meetings.
Yeah.
So this way I got so much exposure and visibility. And then 2 years later, when I started feeling like, oh, okay, well, now it's getting really serious in industry. I can see that, in industry you have to follow, what the industry, what the team wants more. You have to there are some constraints. In academia, you don't have this constraint. So I felt like, oh, okay, I think it's now time for me to be in academia. And I managed to switch really, really quickly, so that was good and easy. Some people say like it's about 2 years. Like if you stay in industry a little bit more than 2 years, it might be hard.
Yeah.
Yeah.
2 years, 4 years, as long as you stay engaged
Right.
and productive, I think
Right.
we all value in engineering industry experience. I
Oh.
don't worry about it. But if I may, there is one more um, branch or field that I tell my students they should look into. So it's
Oh.
industry, academia.
Yes.
Of course, there is national labs, but I call these are more like, in my area, because I work on energy, so it's the
Oh.
national labs. But national labs exist in many other fields, right?
Right.
Manufacturing, many other fields. But there is also a third, so kind of national labs. I consider it kind of like a little bit like industry or in between. But anyway, the third one is actually a policy, like federal,
Oh.
like can
Ah.
can you find a job? Students, the students that are willing to really, go and apply for a fellowship or a fellow position in organizations, I want to say even non-profit,
Right.
and learn the part about how the society works in the social aspect,
Right.
and how, of course, if you can get if you can work under the Department of Energy, under the ARPA-E, they have fellows, all these fellowships, even under national labs, if you can get a fellowship or a summer internship, you learn
Yeah.
so much. And I think that's something that I would advise my students. That is a great entrance
Right.
to
Right.
academia.
I guess that's also run back to your answers when you're saying that to solve this problem, this energy related problem, that is requires a holistic approach, not only from technology, academia, industry, and also, like you mentioned, the policy part. How do we change the societal and make it the equitable solution for everyone? I guess.
Yeah, and regulations. I
Yeah.
mean,
Yeah.
like
Yeah. Yeah.
I keep on working on, let's say, I can keep on working for years and years and years on fuel cells, right? I've been working on fuel cells since 2000. So it's, 20 years, right?
Yeah.
But now I get to see that we should be having that transition, especially for our heavy duty vehicles,
Right.
not to mention for maritime shipping and perhaps even aviation. So this is, but again, if there is a regulation, a carbon tax, some policy that creates incentives, and not just incentives, makes it now a business case.
Yeah.
Yeah.
In order to be able to sell your products, you have to be green and you have to be alternative. Then, hey, suddenly all these amazing type of technologies you were developing and bookkeeping, just staying in the lab, now they can be out on the road.
Absolutely.
So at the end, the policymakers and the regulators need to take advice from us about what is possible.
Right.
So that's what we could do to help
Yeah.
for good policies. But at the same time, we learn the power
Right.
of policy.
Yeah, this is really an interesting area. I think most people probably never really thought about this. I think certainly maybe we can broadcast this to more students can understand this new avenue, right? I think that's super inspiring, can really change some people's career and also create impact. Yeah. I think maybe due to the time limit, maybe maybe you can conclude this interview. Maybe do you want to say something to our division? Anything you want to summarize and before we finish this interview? Yeah.
Well, thank you very much. I think it's been a very rewarding, frankly, experience I've had being part of the DSCD, and so I appreciate taking
Yeah.
time to interview. And I maybe I want to say that I hope we are all get to meet together soon, and if we don't, maybe you can do more of that, and let me know what else I can do to help you.
Yeah, thank you for your time. And I feel like the discussion is very inspiring to me, and also I think also for the audience. And thanks again. Yeah.
Thank you.
Thank you. Take care, please. Yeah.